Alright, welcome. This is 6.3. So at the top you're going to write proving that a quadrilateral is a parallelogram. Okay, so that's our objective today too. So our objective is to determine whether a quadrilateral is a parallelogram. So let's go through really quick and I will show you some of the key concepts that we're going to write down. So you don't need to write these first ones down, but all we're trying to do is we're trying to figure out is if a quadrilateral, a four-sided figure, is a parallelogram. Remember we talked about a parallelogram, the different functions. Okay, so you don't need to write this down yet. I'll tell you when you need to write it down. We'll have them all kind of in one box to make it a little bit easier, but we'll go through these really quickly. So if both pairs of opposite sides of a quadrilateral are congruent, then it is a parallelogram. So if we see these two sides and these two sides are congruent, then it is a parallelogram. As well as if an angle of a quadrilateral is supplementary to both of its consecutive angles, then it is a parallelogram. If A and B and A and D are supplementary, then it is a parallelogram. Okay, if both pairs of opposite angles of a quadrilateral are congruent, then then the quadrilateral is a parallelogram. Okay, so if A and C are the same and B and D are congruent, then it is a parallelogram. Then we have if the diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram. Remember we talked about a parallelogram is when they cut and AE is congruent to EC, and same thing for BE and ED. If those are all congruent, it is a parallelogram. And then our last one is right here, if one of the opposite sides of a quadrilateral is both congruent and parallel. So if one of the sides is congruent and they are parallel, then that quadrilateral is a parallelogram as well. Alright, so we have all the concepts kind of all put together, nice and clean. So I would write down everything in this box, which is everything we just talked about. So we have different ways to prove if a quadrilateral is a parallelogram, and here are some of the ways. First, if we prove that both pairs of opposite sides are parallel, that's one way. If we can prove that both pairs of opposite sides are congruent, that's our second way. Our third way is to prove that an angle is both supplementary to both of its consecutive sides. That would be my third way. If you need to pause it, you can, but we're going to go on and show you the different ways. If we can prove that both pairs of opposite angles are congruent, that's my fourth way. My fifth way is to prove that diagonals bisect each other. And then my last way, my sixth way right here, is to prove that one pair of opposite sides is congruent and parallel. So those are my 6 different ways I can prove that a quadrilateral is a parallelogram. So make sure you have everything in those boxes written down as far as the picture too. That's the most important part, that we have the method and the diagram. Okay. All right, let's do a few problems now. All right, here we go. We got problem number 1 that we have right here. And it says, can you prove that the quadrilateral is a parallelogram based on the given information? Alright, so we are looking at this right now, and the first thing that we notice is that they both have a 5 right there. So both of these sides are congruent. Well, I don't know if these two sides are congruent, so I can't use that method. But I do see that this angle right here is 50 degrees, and this one right here is 130 degrees. And when I add those up together, I'm going to get 180 degrees. And they're on the same side. So remember we talked about same side interior, they're on the inside. If those are supplementary, and we used our converse, remember we said converse of same side interior angles, if those equal 180, then the two lines are parallel. So then I would say these two lines are parallel because the converse of same side interior. And now if these both sides are parallel and congruent, then it would be a parallelogram. Okay. So I'm just going to show you really quick. What we're going to write down is, it's going to show me, let's see what it has. So we're going to write this down right here. Same side interior angles, A and D are supplementary, so AB and CD are parallel. So those are parallel right there, which we wrote. And we say since AB is congruent to CD, then ABCD is a parallelogram. We typically don't do the theorems. You won't have to memorize those. But if you say that they have a congruent and parallel side, that would be sufficient. Okay? All right, let's go on to the next problem. All right, so our problem number 2, it says, can you prove that the quadrilateral is a parallelogram based on the information? So it tells us a couple things first. It tells us that these two sides are parallel and these two opposite sides are parallel. So I'm thinking about the 6 different ways that I can prove it. I don't have any of the angles to figure out whether they are the consecutive angles are supplementary or opposite angles are congruent. I have the sides, but remember, in order to prove the one side, these sides have to be parallel, but they also have to be congruent. So because I don't have enough information, I would say no. So in order for DEFG to be a parallelogram, one pair of the sides must be both congruent and parallel. So these sides could be congruent, but they would also need to be parallel in order for me to use that proof. Okay, so make sure you have that sentence right there written down, and let's go to our next problem. All right, my last problem that we have right here is problem number 3. So it says, a truck sits on the platform of a vehicle lift. 2 moving arms raise the platform until a mechanic can fit underneath. Why will the truck always remain parallel to the ground as it is lifted? So we have this truck right here, and it gives me the different dimensions. And it even has, if I play this right here, we can see that the truck, it's on a lift, so the lift moves up and back, just like that. And so we want to make sure that it is parallel to the ground, so obviously the mechanic doesn't get squished or anything like that. So I got to figure out, I have this shape right here, and I'm trying to figure out, is this shape, can I figure out if it's a parallelogram? That way the two sides will stay the same. Okay, well, I'm looking right here, I have a parallelogram right here, and I see that, well, this side is 6, this side is 6. These two sides are 26, so I see that opposite sides are congruent. Remember, that was one of my 6 ways to prove it. If opposite sides are congruent, then I can say that this shape, which is PQRS, is a parallelogram. And instead of writing a parallelogram, we can just do this shape right here of a parallelogram. So because we know it is a parallelogram, we know that the two sides, both the top and the bottom, will remain parallel. And so that means that QR will always remain parallel to PS, which is what we wanted to know. So we figured out it was a parallelogram by opposite sides being the same. Okay, perfect. We'll do some more work on this in the class. Hope you guys enjoyed. All right, see you guys soon.